All right, guys, I'm going to go over this pretty quickly. Hopefully you understand it. Each slide has a separate recording, so you can go to each different slide for each problem. So the first one I'm going to do is about the card sorting machine. It counted 1,600 cards. There are four different suits in a card deck. So these are the four outcomes that we're expecting. This is what we observed the machine to hand out. What we expect, if you think about it, if there are four cards, you would expect an even opportunity or an even probability of getting each card. If there are 1,600, you'd expect 25% of that. So our expected here would be 400 for each suit of cards. Now, remember I said to you at the beginning, you should really be looking to make sure that, kind of give yourself a prediction. Do you think these numbers are pretty close? Do you think they're too far away from what you expect? It looks to me like these are pretty close, so I would expect that we would actually accept our null hypothesis. Remember that anytime you're doing this, the null hypothesis is that there's no difference between observed and expected. Okay, so I'm basically going to get what I expect on this outcome. So let's take a look. If you remember, the equation for chi-square is going to be the sum of your observed minus expected squared over expected. So I'm going to pause as I go through I'm going to fill out the table and then I'll talk about it. All right, so the math is done. This number right here is my chi-square value. When I looked up on the chart, and I'll show you the chart, I just can't show you on this video. Just remember our degrees of freedom is always outcomes minus 1. We have 4 possible outcomes, which are the 4 suits in a deck of cards, minus 1 equals 3. So 3 degrees of freedom. Remember that our p-value, when we're looking at a critical value table, is always going to be 0.05. When I use that, and you have this on your sheets, but basically the value on this one is going to be 7.8. So 7.8 is quite a bit larger than our 2.48. So in this case, we would accept the null hypothesis and basically state that if we're, writing an FRQ for this, I would basically state that there's no statistical difference between the values of our expected and our observed. Any difference that we see is due to random chance. And we can say this with a 95% confidence. So I hope that kind of explains that question. And really, if you look at the observed, it is not that far off from the expected. And as you get larger and larger sample sizes, the difference has to be pretty large for you to reject the null hypothesis. So that's question 1. Hope that helps. Okay, guys, on to the next question. This question is probably the hardest question you're going to see when it comes to crossing. There are a lot of assumptions we're making. I don't feel like this question is the greatest question in terms of giving you enough information, but I'm going to assume that we've got 2 different genes here. So this is multiple alleles, kind of like blood type, kind of, but maybe a little different. Anyways, if I think of stripes, I'm going to use the letter S. So big S, and big S, little s would be stripes. In a normal situation, little s would be no stripes. Okay, and then for spots, we would have, let's use P for spots. Big P, and big P, little p would be spotted. And of course, little p would be no spots. Okay, and basically what we want to do is a dihybrid cross. So we're basically going to do this cross, and you don't actually have to do the cross, because if you remember in class, we talked about how anytime you have this type of cross, you're going to get a 9:3 to 3:1 ratio, right? Where this one is dominant, this would be dominant, recessive, this would be recessive, dominant, and this would be recessive, recessive. So in this case, we would be looking at both. So they'd have stripes and spots. Here we would be looking at stripes only. This one would be spots only. But this one's a little tricky. This should be a little d. Okay, because we're not going to have an animal that is either not spotted or not striped. So what you can do in this situation is you're going to add this one to one of the 3 out of 16 ratios, right? So you can either add it to the spotted ones or the striped ones. It doesn't really matter. But instead of a 9 to 3 to 3 to 1 ratio, we're going to end up with a 9 to 4 to 3 ratio, because we're taking this 1, because there's no such thing as a non-spotted, non-striped big cat like that. So we're going to put this onto a different ratio. All right, I hope that made sense. So let's go ahead and do our expected and our observed and see how we do. I'm going to go ahead and fill out the table and then talk about it after. I've done all the math, and when I've done all the math, I come up with a chi-square of 4.03. Now I've gone ahead and looked up the critical value. I believe the critical value on the table was 5.99. If you remember how to get degrees of freedom, you take your outcomes. We have 3 outcomes, which is stripes, spots, and both. So our degrees of freedom is n minus 1, which would give us 2. We always use a 0.05 p-value, and that gives us a critical value of 5.99. Now this is our p-value of our chi-square value of 4.03 is less than our critical value, and therefore we are going to accept our null hypothesis and say that any difference we're seeing between observed and expected is due to random chance, and we're 95% confident that the outcome is what we expected. So that is question number 3, even though it was actually question number 2. I hope that made sense. Okay, last question is about pea seeds, and it's asking about the cotyledon. In case you're wondering what that is, that's the little seed, like what's inside of it. And then we're looking at the pod. Is the pod constricted or inflated? So we're basically going to do a dihybrid cross. So let's take a look at a couple of things. We're looking at color, first of all. So I'm going to use Y as the color. So in this case, the cotyledon, yellow is going to be dominant. So that's going to be this, to green, which would be this. Okay, so that's the cotyledon. And then we're also looking at inflation or constricted. So I'm going to use an I for that one. So let's see. It looks like inflated is dominant to constricted. So this would be inflated to little I, which would be constricted. And we're just going to do another 9-3-3-1 ratio. So basically we're crossing this with the same thing. This is an X saying we're crossing those. It's a little confusing with all the letters. All right. So what we should end up with, if we look at the dominant traits, dominant would be yellow inflated. And that would be 9 out of 16. Then we would have yellow constricted. That would be 3 out of 16. We would have green inflated, which would be also 3 out of 16. And then finally we would have green constricted, which is our recessive, which would be 1 out of 16. All right, so that's kind of what we're looking at. Now, if these are inherited independently of each other, meaning they assort independently, we would get this ratio right here. Okay, so we're going to check and see if that's what we got in this cross, and let's see how we do. So I'm going to pause again as I do the math. I'll set up a table and kind of go over it once it's done. Okay, so just from looking at the numbers, I really don't even need to do a chi-square, but I will. You can look at those numbers and see they're very, very close to the expected numbers. And when you do the calculations, when you get numbers this low, you know you're basically going to accept your null hypothesis. I mean, just looking at these numbers right here, I can see we're basically in a 9-3-3-1 ratio. So, but, you know, scientists like a lot of data. We like to be able to say we're confident in it. So let's take a look at it. So we have 3 degrees of freedom. Remember that this is n minus 1. We have 4 outcomes. So 4 minus 1 would be 3. We always use a 0.05 p-value for 95% confidence, and our critical value is 7.815. Obviously, 0.312 is quite a bit lower than 7.815. So we can say with a high degree of confidence that there's no difference in the observed and the expected, and that any difference we're seeing, which isn't much, is due to random chance, and we will therefore accept our null hypothesis. That's it for this homework. I hope it helped, and have a great day.